This is a video lesson for Module 1, Lesson 16. The Lesson 16 learning target is I can solve two-step word problems using the standard algorithm for subtraction, fluently modeled with tape diagrams, and assess the reasonableness of answers using rounding. So pretty big learning target here, but essentially what we're going to be doing in this lesson is solving word problems with subtraction that involve more than one step, and then we're going to be using tape diagrams to help us understand the problems and rounding to help us check to see if our answer is reasonable. So let's look at a few examples here to help us with the story problem solving process. The first problem here reads, a company has 3 locations with 70,010 employees, altogether. The first location has 34,857 employees. The second location has 17,595 employees. How many employees work in the third location? So let's go back into the problem and underline some of the important information. The first important information is that there are 3 locations total, and that the first number we see is 70,010, and that's the employees all together. This number altogether is really important because this is going to be helpful when I'm drawing my tape diagram. Then we have the first location has 34,857 employees, and the second location has 17,595 employees. And then of course the question is, how many employees work in the third location? So to start with this problem, I'm going to draw a tape diagram to model what this problem is asking me to do. When I draw the tape diagram, when I'm able to draw it effectively, I'm able to see kind of the steps I need to take in order to solve the problem. So first I'm going to start with this number right up here. Since this is the number that's the number of employees altogether, I know that that's going to be the total number of my tape diagram. So that word altogether is really helpful there. Then I'm going to split my tape diagram into 3 different chunks because there are 3 different locations. I know the first location has this many employees in it, so I'm going to add that to my tape diagram. And the second location has this many employees. I'm going to add that to my tape diagram. And so what it looks like I need to solve is the amount of employees at this third location. So looking at this tape diagram, I can kind of give myself some steps to solve this problem. I can identify the 2 steps pretty easily. So when I'm looking at this tape diagram, it looks like what I'm going to need to do is I'm going to need to find the total of these 2 parts together. And then once I find the total of those 2 parts, I'm going to subtract the sum of that answer from the total of the whole tape diagram. So essentially what I'm going to do is add location 1 and 2 together. And then the second part, I'm going to subtract the sum from part 1 and subtract from the total. So now that I have a little action plan here, I'm going to put it into place. So the first thing I'm going to do is add location 1 and 2 together. So I'm adding this number to this number. So I'm just going to use a standard algorithm for addition for this problem. And I'm going to go through it rather quickly here, just so I can get through the whole problem solving process. So I get a sum of 52,452. So now that I've checked off my first step, I'm going to move on to my second step, where I'm going to subtract this sum right here that I just found from the total of the tape diagram. And that's going to get me the third location number that I'm looking for. So I'm going to set up the problem using the standard algorithm for subtraction. And once again, I'm going to solve this using the standard algorithm. I'm going to go rather quickly. So if you're needing a refresher, on this process, please feel free to watch the two previous video lessons, 15 and 13, and those can give you a more broken down, step-by-step problem-solving process for the standard algorithm. All right, so I get my answer of 17,558. So now that I've found my answer, I'm going to check the reasonableness of my answer by rounding each of the numbers in my tape diagram here and seeing if my answer is reasonable. So I'm going to round the 3 locations, and it should be close to this 70,000. So I'm going to round each one to the nearest 10,000, so 34,857 is approximately 30,000. 17,595 is approximately 20,000. And 17,558 is approximately 20,000. So if I add these 3 together, 30,000 plus 20,000 plus 20,000, it's approximately 70,000, which is super close to my original total, so I know that my answer is correct. So now all I have to do is I have to write a statement with my answer in it. So I write my statement here. The third location has 17,558 people. And I'm going to go ahead and circle my answer so everyone knows that that is my answer right there. So that's one problem solved all the way through using the problem-solving process, drawing a diagram, listing the steps, and then estimating to check the reasonableness of our answer. We're going to take a look at one more problem here to give us one more example of how we can use this process to solve story problems. So let's get this in the view here. Excellent. So there were 12,345 people at a concert on Saturday night. On Sunday night, there were 1,795 fewer people at a concert than on Saturday. How many people attended the concert both nights? A little bit of a trickier problem here, but let's break it down so that we can really understand it well. So this is the amount of people on Saturday night. And then on Sunday night, there was this many fewer people. So this number fewer is really, really important. It's really important to recognize that word right there, because if we don't, our whole problem-solving process is going to be off. And now the question we're answering is how many people attended the concert both nights. So I'm going to draw tape diagrams here that model the amount for Saturday and Sunday. So for Saturday, looks like we just have the total of 12,345. And for Sunday, we have 1,795 fewer than Saturday. So I'm going to draw a tape diagram that's equal to the one for Saturday. But then I'm going to draw a little dashed line here and show that this is 1,795. So this is taken away from the total of Saturday. So I don't know how much is on Sunday. And I also don't know what was the total of the two together. So drawing my tape diagram like this helps me figure out what I actually need to do to solve this problem. So it looks like first I need to subtract 1,795 from 12,345 to find Sunday's total. And then once I found Sunday's total, I'm going to add Saturday and Sunday totals together. Okay, so now that I have my two steps, I'm going to go ahead and solve. So the first thing I'm going to do is I'm going to subtract 12,345 minus 1,795. I'm going to use the standard algorithm here. I'm going to go pretty quick just to solve. So here we go. So I get an answer of 10,550. So this is the total for Sunday. So now that I know the Sunday total, I need to move on to my second step, which is to add Saturday and Sunday together. I'm going to use the standard algorithm to solve this problem pretty quickly here. And I get a total answer of 22,895 people on both nights. So I'm going to circle my answer here. Now to check, I'm going to use some estimation just to check the reasonableness of my final answer here. I'm going to round these two values, 12,345 and 10,550, and see if when I do that I get somewhere close to my final answer. So 12,345 is approximately, around to the nearest 1,000 here, it's approximately 12,000. 10,550 is approximately 11,000. And if I add those two together, it's about 23,000. And that's pretty close to my final answer. So I would say that my answer is very reasonable. It's close to my estimate. So that does it for the lesson 16 video lesson. So at this point you should be feeling pretty comfortable about solving these two-step problems using this problem-solving process of drawing a model, thinking about the steps, and then going ahead and solving it with the standard algorithm. So at this point you should be able to tackle the problems in the lesson 16 problem set. But of course, if you need a refresher or get stuck, you can come back and watch any of the video lessons to help you out. So good luck with the problem set, and thanks for watching.